physical magic, where the things together is magical. So let's talk about equilibrium. As you've seen in a lot of videos, they keep asking a question about resultant force equal to 0, resultant torque equal to 0, or one of them not being equal to 0. Equilibrium, so far we know it's an object at rest. We know it's a stationary object. So how do we define equilibrium? Equilibrium actually has two main conditions. The first condition is resultant force in any direction is equal to 0, or just put no in front. No resultant force in any direction. B, no resultant torque or moment about any point. Okay, point means pivot in this case. And I use torque because sometimes instead of moments, they use torque to remind you, sometimes they might interchange this. So when you see this definition in the mass games, don't worry about it, they're just talking about a current. So you want to put moments, they'll give you the mark. You want to put torque, and give you the mark. Okay? In the previous videos, you already seen this one. This is quite easy to indicate this one. You just need a point mass technique. So upward force must be balanced by the downward force. You got the horizontal forces, left must balance by right. When you have a force like this, means the object literally cannot move either upwards, downwards, vertically, or horizontally. Okay? And that means it literally is stationary. That is what it means by equilibrium. However, if an object like this, the forces are balanced, what about this one? How do you actually find no resultant torque? One of the questions we did in the previous episode was quite nice. I hope you remember the three forces diagram, where you have to check that if you choose this as pivot, your forces are your moments will still balance. If you choose this instead to pivot, these two forces will balance. It's quite obvious here. If you choose this as a pivot, these two should balance. So hopefully, I hope you have come to check that question, which I asked you to check on pivots, to check all the resultant moments or torque is equal to 0. Okay. So when equilibrium comes, please remember these two easy marks. Just remember no resultant force in the direction, no resultant torque. Basically, if an object is falling and is rotating, it means completely no equilibrium. Okay? Object falling and rotating. You can also have an object which falls but does not rotate, meaning there's no resultant torque, but there is a resultant force. You can also have an object that is rotating but not moving. Okay, rotating but not moving means the force is actually balanced, which in this case quite well known. You can remember this as that example as a car. I hope you get a good idea of this. We have done a lot of episodes before this to understand this concept right now. Now I throw in the definition so you can use it quite efficiently. So I hope you understand this video. If not, replay this with the other videos to understand about what I mean by this, what I mean by this, in order to get an object to be completely stationary. Okay, completely stationary means equilibrium